The world's largest commercial airliner is coming apart in mid-air.
We're losing an engine.
There was fuel leaking from the aircraft. There was damage to the aircraft flight controls.
Pilots face an avalanche of warnings.
What have you got for me now?
Critical systems are failing throughout the gigantic plane.
What's going on up there?
The lives of 440 passengers are at risk. And the crisis quickly escalates from bad
It's one system after another.
to catastrophic.
Computer says we can't make it.
Damn it.
This is like the simulator exercise from hell.
Mayday, mayday.
Qantas Flight 32 is making a refueling stop in Singapore. The Airbus A380 is more than halfway through a marathon 22-hour flight, all the way from London to Sydney, Australia. After 2 hours on the ground, the crew is nearly ready to get the plane back in the air. Very few pilots are trained to captain an A380. Former fighter pilot Richard de Crepney is in that elite rank.
Everyone ready for takeoff?
The A380 is the latest generation of innovation, automation, and excellence. And it's the largest, most complex aircraft in the sky.
The main duty on this flight for First Officer Matt Hicks is to monitor the vast number of electronic gauges and computer displays needed to fly this state-of-the-art plane.
Everything's looking good here, Richard.
All of us had flown together at some stage. It just makes it easier because there's no first day greetings or, personality uncertainties. Everyone knew each other pretty well.
Mark Johnson is the second officer.
Mark, any worries?
All good back here.
The three pilots will take turns flying the plane during the remaining 7 hours of the flight. The gigantic A380 is a true double-decker, the first jet ever built with 2 decks running the entire length of the plane. It dwarfs every other airliner in the sky, with enough space for as many as 525 passengers.
I hadn't realised the enormity of how large a 380 was. The cabin, the inside of the A380, just everything seemed bigger, but more rows and upstairs.
On today's flight, Captain de Crepney's performance is being evaluated. It's a yearly requirement for every Qantas pilot. The Czech captains performing the task are veterans Harry Wubben and Dave Evans.
Some people are affected by checks. They get a bit nervous, so we try to keep that as easy as possible.
Okay, so everyone's happy.
Richard, obviously just being checked, he's a bit, tentative, taxing out. So when he asked if everyone happy, I said, yeah, I'm happy.
Just don't crash.
Qantas 32 cleared for takeoff, runway 20 center.
Qantas 32 cleared for takeoff. Okay, on the roll. Thrust set, 80 knots.
The more automated aircraft get, it doesn't necessarily make them easier to fly. It just makes them different to fly.
The A380 is powered by 4 massive Rolls-Royce engines. Each can deliver 72,000 pounds of thrust.
They designed wonderful engines, very reliable.
V1, rotate.
At 9:57 a.m. local time, Qantas 32 lifts off right on schedule. Passengers get a unique view of the takeoff, thanks to a camera mounted on the A380's tail.
The atmosphere in the cabin was perfectly casual. We were chatting away the whole time since we were seated.
There are 250,000 sensors monitoring every flight function on the aircraft.
Autopilot. On.
This is by far the most automated passenger jet in the skies.
Climb out checklist, please. Auto thrust is set, and ECAM is clear.
The ECAM, or Electronic Centralized Aircraft Monitor, keeps watch over the myriad of onboard systems and alerts the crew to even the slightest malfunction. It's 10:01 a.m. The pilots are just 4 minutes into the flight.
We're losing an engine.
Boom. Boom. It's like a backfire in your car.
There was the loud explosion, huge explosion, and everybody just said, "What was that?" My reaction immediately, I think, was, "Oh my goodness, maybe this is it."
The first thought when it goes bang is engine failure, possibly severe damage.
We've lost number 2. Holding 7,400 feet.
De Crepigny wastes no time taking over control from the autopilot. 35 years of flying tells him what to do next.
I press the altitude hold button, which will cause the nose to lower and the aircraft level.
Matt, ECAM actions. On it.
The captain assigns Hicks to decipher the ECAM data. He needs to evaluate every message and figure out how best to react to each one.
We had to work our way through it and build up a picture of what was going on with the aeroplane.
While the captain summons all his skills as a pilot, Hicks needs to quickly master the plane's ECAM computer. He's facing a barrage of error messages from seemingly unrelated systems throughout the plane.
You can't really tell how many messages you've got pending. You know there's more coming because the screen will give you an arrow at the bottom indicating that there is another message.
It became very confusing initially as to why we were seeing so many of them.
Captain de Crepigny needs room to maneuver.
Pan, minus 32, engine failure, maintaining 7,400 and current heading.
Qantas 32, copied. Please let us know how to assist.
I declared a pan call, and what that does is tell everyone who's listening, we have a problem, tells air traffic control, clear the airspace, and to not annoy us with transmissions. Let us solve the problem.
But the ECAM warnings just keep coming.
Number 2's overheating.
Their damaged engine is dangerously hot. This state-of-the-art plane is now in very real danger of becoming a fireball.
But we couldn't actually see the engine itself because it was under the wing.
Oh my God!
But we could see the stream of the fuel coming out.
The wings of an A380 are filled with tons of highly flammable jet fuel.
We were all just wondering what was going to happen next.
The crew wants to cut the flow of fuel before the damaged engine catches fire.
Number 2 master switch to off. Confirmed.
But it's too late. An alarm warns the crew the engine is on fire. An in-flight fire is one of the most dangerous and unpredictable emergencies any crew can face. It's nearly always disastrous. July the 11th, 1991. Smoke begins seeping into the cabin of a DC-8 moments after takeoff from Jeddah, Saudi Arabia. As the pilots try to land, flames sweep through the entire cabin and consume the plane, killing all 261 people on board. On Qantas 32, the crew's only hope of putting out the fire is to activate the emergency extinguishers inside the burning engine.
Fire number 2. Push button. Confirmed.
And keep their fingers crossed that it works.
Warning's off. I think the fire's out. Let's find a way to confirm that, please.
It was stressful. It was difficult.
I mean, if you had a fire burning out on the wing for the duration of the flight, you'd be landing pretty quick smart rather than taking your time flying around trying to solve other problems.
Marion Carroll is sitting over the left wing, giving her a front row seat to the unfolding calamity.
I could see the hole that was in the wing that had been made by the explosion. And it seemed, from what I could see, quite a large hole, like about a couple of feet across, and all the metal was jagged and sticking up.
6,300 kilometers away, the Qantas Operations Centre in Sydney is getting data transmitted live from the plane. It's like nothing engineer Alan Milne has ever seen before.
Getting some odd messages off Flight 32.
When we saw the messaging coming in from the aeroplane, it was so diverse, so many systems, we couldn't just put a finger on it.
Meanwhile, on Batam Island, Indonesia, locals are finding evidence of an air disaster. The wreckage sparks media speculation that a Qantas plane has fallen from the sky. At the Australian Transport Safety Bureau, Kevin Chapman gets word of disturbing media reports. If true, he knows he'll soon be facing the biggest investigation of his career.
The Australian Transport Safety Bureau monitor media, and we were well aware through the media coverage that there was some sort of event. The initial event described in the media was an aeroplane had crashed off Indonesia.
Damn. An A380's gone down in Indonesia, Qantas.
So we were quite concerned at that point.
Explosive engine failure has led to fatal tragedy in the past. July the 19th, 1989. A United Airlines DC-10 bound for Chicago loses an engine mid-flight. Shrapnel severs hydraulic lines, making the plane nearly impossible to control. The crash landing in Sioux City, Iowa kills 111 of the 296 people on board. Back aboard the A380, First Officer Matt Hicks has begun working his way through a growing avalanche of computerized warnings. The crew must correctly react to each and every message before moving on to the next.
Okay, I've cleared slat 1 and 2. What have you got for me now? Hydraulics.
It was like taking plates off a serving machine in a restaurant where you do one checklist and there's another one. You do that and there's another one, and another one, another one, and another one, another one.
In a training environment, you probably only do 2 or 3 consecutive failures. And in this case, I think we had 58, so it was, yeah, a lot more than I'd ever worked through before.
It's been 5 minutes since the plane's number 2 engine exploded. Qantas 32 is 70 kilometers south of Singapore and heading out over the open ocean. The pilots want to turn back, but making a U-turn is risky without knowing how badly damaged their plane is. The list of failures continues to grow, taxing the pilots' abilities to respond. One wrong move on their part could lead to one of the deadliest air disasters the world has ever seen. Engineers at the Operations Centre are also trying to make sense of the cascade of errors. Qantas 32 seems to be failing in almost every conceivable way. No one knows how long the plane can stay in the air.
It's one system after another.
My initial impression was that it might have actually been an indication problem, that the aeroplane was sending us false error messages.
What's going on up there?
Degraded pneumatics, hydraulics, electrics, power to the left wing shut down, flaps, slats, and ailerons are damaged but operable.
Dave, I need you to get on the horn to the passengers. Let them know our situation.
Ladies and gentlemen, we're just sorting out some engine problems.
He was very calm and very reassuring, and I mean, it was his tone of voice that was very reassuring.
Captain de Crespigny knows he's running out of time. The failures are mounting. His plane may soon be unflyable. He needs to get the damaged plane on the ground. That means turning around and heading back to Singapore.
Singapore, Qantas 32. We require a left turn back towards Singapore.
Qantas 32, Singapore. Turn left, heading 020.
Are we stable enough for this turn?
We'll know pretty soon.
De Crespigny takes it inch by inch, knowing that he could lose control at any moment.
It takes time to prepare the aircraft to land, to understand the aeroplane that we're going to land. But as the time goes on, things are getting worse. So we don't want to stay 1 minute more in the air than we have to.
Singapore is the largest airport within 350 kilometers. Its massive runway offers the best chance of landing the plane safely.
Singapore runway is 4 kilometres long, and we would normally need 1,800 metres to land on the runway if we're at maximum landing weight. But we are 40 tonnes over our maximum landing weight.
De Crespigny completes the turn back to Singapore. The maneuver gives the crew confidence that they have some control over this juggernaut. Making a left turn is one thing. Landing the crippled A380 will be quite another. The pilots need to know more about the damage and its possible effects.
Mark, why don't you go back and take a look at that wing?
On my way.
We couldn't see the wings from the flight deck, we can't see the engines. So Mark would be our eyes and ears to the aircraft.
After a couple of minutes, one of the pilots came out and was looking down each window. And I called to him and said, well, if you come down to my row, you'll get a much better view of the hole in the wing.
The second officer gets a sobering view. Johnson can clearly see that the wing has been punctured straight through from below. The cause of the damage is obvious. The inboard left side engine is blown to pieces.
Is it bad?
Oh, we'll be fine. No worries at all.
What can you tell me, Mark?
Number 2's blown apart, cut holes through the wing, and we're leaking fuel.
Good to know.
It was invaluable to send someone back to physically eyeball the damage on the wing, and to have a pilot come back to you and say, hey, look, this is the situation, and especially someone you trust. That's as good as you having a look yourself.
The news helps explain why so many systems are failing. Vital flight controls run through the wing. Shrapnel from the demolished engine has likely destroyed many of them.
There's obviously a lot of hydraulic components that run through the wings, so that would make sense that we'd have damage to the hydraulic system. It sort of clarifies a lot of the information that you see.
We had so many checklists, 100 in the air, that it took Matt 55 minutes to stabilise the aircraft so that this aircraft situation didn't get worse. That is unprecedented in aviation history.
Knowing why the plane is failing doesn't make it easier to fly. The damaged electrical and hydraulic systems could cause an unexpected failure while the crew is trying to land. The pilots decide to circle near the airport until they can work out a plan.
Dave, I need you to run the numbers on this landing.
Check Captain Dave Evans is called into action.
3 engines, full load, all that.
He uses the A380 landing software to calculate how much runway they'll need to bring the huge plane to a stop.
The computer says we can't make it. Runway's too short.
With the 9 failures that I put into the system and the surface conditions in Singapore, at our maximum landing weight, I couldn't come up with an answer.
The A380 is weighed down with fuel. The plane has burnt almost none of the 105 tons it took on for the flight to Sydney.
Can we dump some fuel?
That's a good idea, but we can't. Fuel transfer pumps are down.
Damn it. Can someone tell me what is working?
The heavy load of flammable fuel means any landing attempt will be extremely dangerous.
We were some 40 tonnes above our maximum landing weight, and the heavier you are, the more runway and the higher speeds will be on your approach.
Evans tries his calculations again. The computer has assumed a worst-case scenario. He now plugs in some more optimistic numbers.
There is a belief in part of the industry that computers are infallible and you always believe a computer. Now, we've used our computers at home to know that's not true.
Okay. Looks like we can do it, with 139 metres to spare.
139 metres surplus on a 4,000 metre runway is a slim margin, but it's better than a minus 139 metres.
What do we need for our approach speed?
146 knots.
146 knots. That can't be right. It's just too slow.
He gave us that speed to input into our flight management computer, and before I input it, I just had to think about it, and I thought that just can't be right. It's just too slow.
Maintaining the right speed on landing is critical. Too slow and the plane will lose lift and plummet to the ground. Too fast and they could run off the end of the runway and crash.
At 20 knots, can we still stop in time?
Good catch, Matt. Yep, 166 works.
I like to think that we sucked the brains dry of all the pilots in the cockpit to make one massive brain, and we used that intelligence to resolve problems on the fly, because these were unexpected events, the unthinkable events.
At the Qantas Operations Centre, Milne sees that Qantas 32 has begun its final descent. Now all he can do is hope the crew can safely execute this treacherous landing.
They're doing it. QF-32's coming in.
He alerts personnel at the airport to prepare for the emergency landing of the biggest airliner on Earth. A landing that could end in disaster for 469 passengers and crew.
We know these guys personally, we know the cabin crew, and you know, it's a worry.
Singapore approach, Qantas 32, we're going to need a long approach. And better have fire services standing by, we're leaking fuel.
Roger, Qantas 32, you're cleared straight in on final, 20 miles.
The 5 seasoned pilots now use everything they've ever learned about flying.
Flaps 3.
To try to land their plane safely.
Here we go.
De Crepigny still doesn't know if his plane is capable of the precision needed for a landing.
4,500 feet.
He decides to find out while there's still room for error.
Okay, I'd like to do a control check.
An aircraft where the aerodynamic ability is unknown. You have to prove the aircraft to be safe to fly before you land. And they are called control checks.
Okay, let's see what you can do.
Captain de Crepigny rolls the plane carefully left to simulate lining up with a runway.
We had degraded roll control. We had lost 65% of our roll control. So I knew that we had to certify the aeroplane ourselves to fly before we landed.
Okay.
As he rolls the plane to the right, there's barely enough control to achieve the maneuver. He's quickly learning the limits of his damaged plane.
If the few flight controls that we have remaining are working to their limit, then clearly we have very little margin for manoeuvring when we come into land.
When we did those control checks, I thought it was a bit sluggish at the time, and I think Richard did as well.
The crew knows they'll only get one shot at lining up with the middle of the runway. There can be no last-minute adjustments. Now the crew discovers a potentially catastrophic obstacle.
Landing gear hydraulics are still offline.
The automated system for lowering the landing gear is damaged. They can only release the gear and hope it falls hard enough to lock itself in place.
Landing gear down.
Confirmed.
If the gear doesn't lock, the crew has no hope of landing safely.
For the landing gear, we just needed enough wheels to hold the aircraft with enough brakes to stop us.
It takes a full 2 minutes for gravity to pull the landing gear into position.
Full green. Confirm gear down.
You can hear the air noise change as the wheels extend. That's always a comforting sound to hear them come out.
We're always told anyway that the takeoff and the landing are more critical. So one was conscious that we were moving into a more dangerous time coming into land.
Qantas Flight 32 is now just 2 minutes from touchdown.
Better watch your speed, Richard.
Okay, just a little bit slower.
De Crepigny adjusts the throttle so that he'll touch down at the slowest speed possible, making it easier to stop.
Airspeed low. Damn, not that slow. Airspeed low.
The Airbus is getting close to stalling. The plane will lose lift and drop like a stone if the airspeed falls any lower. Too fast, and the plane won't stop before reaching the end of the runway. It's a precarious balancing act.
There it is. Speed is stable.
We sped up 3 knots, we would run off the runway. We slow down 1 knot, we get a speed warning.
De Crepney's ability to keep his plane lined up with the runway is severely limited.
Singapore, what's the surface wind?
170 degrees at 5 knots.
If the crew misses the runway, there's no way the crippled plane can go around for another try.
Everybody ready?
At the end of the day, it just came down to, I think we've covered everything. Can anyone think of anything? No. Okay, let's go and do it.
Confirm fire services standing by.
Affirmative. 100.
You think about your kids, you think about your wife, and that's just what you do, and then it was game on again.
50, 40, 30, 20.
Just a few feet from the ground, Flight 32's stall alarm again warns of impending disaster.
So that threw questions up in my mind. What is our performance? Is our performance correct? It doesn't appear to be.
We as passengers were not aware that so many things had gone completely wrong.
The plane is gobbling up 80 meters of runway every second.
We had lost 1 reverse. We had half the spoilers on the wings not working. We had the ailerons not making a speed brake action.
If they don't slow down quickly, they risk overshooting the runway and hitting terrain that could rupture the plane's heavily laden fuel tanks.
We just weren't slowing down.
Get into it!
Matt yelled out,
Get into it! Brakes!
Brakes, brakes, Rich. Put on the brakes. Pump them, push them.
Brakes, full brakes, Rich!
I think I prompted him to brake harder, and he said,
My feet are flat to the floor! Keep it in, Rich! Hammer them!
Finally, after a grueling 2-hour ordeal, Qantas 32 comes to a stop on the same runway it took off from, with 150 meters to spare.
Hallelujah.
Beautiful.
Oh. Welcome to Singapore, guys.
I'm truly proud of everyone in the aircraft that day, the technical crew, the pilots and the cabin crew. And I'm really proud of the decisions we made, the way we worked as a unified, cohesive team.
I thought as I'm sure all the other passengers did too, that the crisis was over, that we'd landed back safely. It seemed like that was the end of the problems.
But with fuel leaking beside red-hot brake discs, the danger is far from over.
There was smoke coming from the left-hand undercarriage, and there was fuel pouring all around it.
Passengers could see the fuel coming out of the wing. We had alarm bells in the cockpit now. The situation was almost as bad as it was in flight after that engine exploded.
A plane that made a narrow escape in the air is now in grave danger of going up in flames on the ground.
I kept looking at my watch at that point. It was quite tense for me inside, in that I couldn't see why we couldn't get off.
This is the captain. I want the passengers in their seats until the fire crew does its job.
Why are they taking so long?
So it was important at that tense moment to lay foam and reduce the possibility of fire as best we could.
While the fire crew lays down fire-retarding foam, de Crepney faces a difficult decision. Keep the passengers on board or evacuate the massive plane.
And the only answer I can give to anyone saying why did or didn't we evacuate is, with someone in your home, are they safer in your home or are they safer somewhere else?
The argument for getting them off? British Air Tour's Flight 28 in 1985. A 737 abandons takeoff after an engine overheats and bursts into flames. The pilots brake and steer onto a taxiway. An evacuation gets underway in seconds. But the fuel-fed fire is filling the cabin with smoke. Firefighters respond quickly. For many on board, though, it's already too late. They've been overcome by toxic fumes. Of the 137 people on the plane, only 82 survive. De Crepigny knows that the plane's 16 escape slides can get all the passengers off the plane in 90 seconds. He also knows there's a high price. 5 to 10% of his passengers will likely suffer a serious injury.
And an evacuation, once that starts, you can't stop it.
And we decided to keep them on board because the environment outside the aircraft was toxic.
For the time being, de Crepigny thinks his passengers are safer on the plane than on the fuel-soaked runway.
Turning engine master switches to off.
The crew begins the routine of shutting down their engines.
Qantas 32, please shut down engine number 1.
A radio call from the fire chief alerts them to yet another problem.
We've shut them all down.
Damn it, he's right. Number 1 is still running. Shut it down.
It's not. I can't shut it down.
The damage to the left wing has cut through the controls that should have shut down the outboard engine.
We now had an engine that we could not shut down, and the situation is now just getting more toxic outside. It's not meant to happen this way. This is like the simulator exercise from hell.
Firefighters can't do their job with one of the largest airplane engines in the world still running a few meters away. They call Qantas engineer Alan Milne in Sydney for advice on getting it shut down.
Well, blast with all the water you can.
They fired one of their high-rate water cannons straight down the front of the engine. Remembering, of course, these engines are designed to fly through some pretty torrential rainstorms, and no matter how hard they tried, they could not get that engine to shut down.
It takes a full hour, but emergency crews finally lay down enough foam to eliminate the risk of a fuel fire. They move stairs into place, which are safer than escape slides. This will no longer be an emergency evacuation.
Ladies and gentlemen, thanks for your cooperation.
The aircraft is now secure, and we can let you off.
It's finally safe for the passengers to get off the plane.
When we finally walked off the plane, there was a great sense of relief, and I noticed my legs were shaking, which I kind of thought, oh, why are my legs shaking? I guess maybe I must have been a bit more nervous than I was aware.
All the passengers make it off the plane safely. But engine number 1 still refuses to shut down.
Yeah.
We're not having any luck with the fire hose. What else can we do?
Try firefighting foam, see if that will shut it down.
Eventually, we had really no option other than to switch to the foam, the firefighting extinguishant foam, and fire that down the front of the engine, and that managed to shut it down.
3 hours after their dramatic landing, the pilots get the all clear.
Qantas 32, I'm happy to confirm that the engine is finally shut down.
Thank you, Singapore. See you on the runway.
Good job.
Well done. Well done, Mark.
Minutes later, the flight crew gets its first look at the damage.
I was shocked. I'd never seen such extraordinary damage to an aeroplane before.
Later that day, Qantas CEO Alan Joyce makes a stunning announcement.
We would suspend those A380 services until we are completely confident that Qantas safety requirements have been met.
It was our CEO himself that asked the question, can you assure me that we won't have this failure again on one of our aeroplanes? And we couldn't answer yes to that.
The future of the entire Qantas fleet of A380s now depends on understanding what went wrong inside one single engine.
There's really only a very select number of companies that produce the large engines, the large turbofan engines, and Rolls-Royce is up at the top.
What a disaster. I've never seen anything like it.
Simon Grummett is a materials engineer with the Australian Transport Safety Bureau.
Everywhere you looked, there was shrapnel, debris, and holes in this thing. So it was quite significant, and that was the initial response. And from that point onwards, we knew that this was going to be a big investigation, particularly for the ATSB.
Yes.
The severity of the damage adds pressure to find answers.
An uncontained engine failure is a pretty rare event, even for an investigator to that's performing this line of work, to actually, this is the job. Okay, this is the one that counts.
The debris that fell to the ground includes a broken engine turbine disc. It's made of nickel alloy and is one of the most robust parts of the airplane.
Now let's get this back to Rolls-Royce, see what their guys think.
We knew that we had a turbine disc failure. The next stage was to find out why the turbine disc had actually failed.
The 160-kilogram disc is one of the most critical parts of the engine. Its massive fan blades can reach the speed of sound as they move air through the engine for combustion. In the lab at Rolls-Royce, engineers compare the disc to its manufacturing records and notice something odd. The disc is larger than it should be. It tells investigators that it was spinning at an almost unbelievable speed. So fast that it actually began to stretch and grow wider.
And it gets wider and wider and wider until the ultimate strength of the material is reached, and the disc will generally fly apart. It occurs with such violence that the fragments are released with an infinite energy. And what that means is that there will be nothing which can stop those engine pieces.
It ripped through everything in its path. Wires, hydraulics, everything.
Investigators trace the path of the debris through the plane. Pieces from the engine have clearly sliced through the fuselage and the left wing.
No wonder they had so many failures.
Severing fuel lines, hydraulics, and flight controls. The damage explains why the pilots received so many error messages after the engine exploded. But it doesn't explain why the disc was spinning so fast in the first place. Investigators take the engine apart, searching for anything that could explain the catastrophic failure of the turbine disc.
The disc had failed from overspeed, and that there was no contributing factors in regards to the manufacture or design of the disc itself. At that point, the focus went back onto the engine.
They discover something disturbing.
Oil fire.
In a Rolls-Royce engine.
The inside of the engine is burnt black and covered with soot and oil. The evidence tells Grummett that the fire was fueled by oil. The engine must have suffered an oil leak. Grummett examines the engine further, searching for the source of that leak.
Kev! It's at that point that actually the IAC walked in to the disassembly area, and I called him over and I said,
Kev, I think we got it.
At that point, it was oh wow, this is a really important moment of the investigation.
A narrow pipe has snapped off, releasing oil into the area around the turbine disc. The broken part is called a stub pipe.
This nearly brought down an A380. Jeez, man.
Investigators believe that oil from the broken stub pipe ignited and burned at more than 1,000 degrees Celsius.
Fire number
32, push button.
The fire damaged the drive shaft, allowing the turbine disc to spin faster and faster until it broke apart and tore through everything in its path. There was nothing the crew could have done to prevent it.
Once a fire is established inside a gas turbine engine, it's nearly impossible to put out other than physically shutting down the engine. In this case, the internal oil fire happened so quickly and accelerated that the crew had absolutely no opportunity to shut down that engine before the engine failure.
Investigators now have a prime suspect. But what caused a simple stub pipe made by one of the world's most esteemed engine manufacturers to break and nearly destroy a $400 million airplane? Investigators send what's left of the stub pipe to its manufacturer, Rolls-Royce, where a disturbing discovery is made. One side of the pipe is much thinner than the other. That's what allowed it to break apart, spraying the engine with oil and causing a near-catastrophic fire.
It's no wonder it cracked. We're only talking it was 0.35 millimeters in thickness. It's a couple of sheets of paper.
Investigators study the manufacturer's report. They learn why one side of the stub pipe was so dangerously thin. It was due to a manufacturing error.
The investigation was actually quite surprised that such a mature organisation, such as the engine manufacturer Rolls-Royce, could be in that situation.
The ATSB immediately takes steps to alert other airlines that their A380s are at risk. Just 29 days after the accident, they issue a report warning that a faulty stub pipe caused a fire that led to uncontained engine failure on Qantas 32. They advise airlines to inspect their fleets.
The question that was put forward was, what are you going to do about this?
ATSB Chief Martin Dolan soon has an answer from Rolls-Royce.
And if the problem is detected in any of the engines, those engines will be taken out of service.
There are 20 A380s with the same Rolls-Royce engine in service around the world. 34 engines are found to have suspect oil pipes.
As a result of this investigation, all engines that had non-conforming oil feed pipes have been removed from service. Rolls-Royce have made significant changes to their quality management system. They introduced a software program which basically removes fuel from the engine in a similar event.
Investigators conclude that Flight 32 ended safely because the well-trained crew responded quickly and effectively, even when aviation's most sophisticated technology failed them.
Matt, ECAM actions.
He kept his calm, he followed the procedures, we worked the checklist.
What do we need for our approach speed?
146 knots.
Can't be right. It's just too slow.
Add 20 knots.
166 works.
Yeah, they would have stalled at 146. And then there's this gutsy move.
Okay, I'd like to do a control check.
The captain's decision to get a sense of what his plane was capable of at a safe altitude gave the crew valuable information about how their aircraft would perform on landing.
What a crew.
A modern aircraft like the A380 is full of automation, but like any piece of automation, it can fail. So the human element is always necessary.
You can see the whole team working together to deliver an outcome under adversity in situations such as this, and it's the right outcome.
It's not about me as a pilot in command of QF-32. It's about aviation that for the last 110 years has shared their knowledge and experience to make aviation safer for the travelling public. I think in every regard, the Qantas 32 story is one of aviation's finest hours.
Remember the headlines about the pilot who crash-landed on a river in New York? Survivors tell their incredible story in brand new Miracle Landing on the Hudson, next.